Jai Jagannath friends, we have already studying real analysis, topology and algebra, which are three papers of MSc first year or first semester in Indian universities. And now with this video friends, we are going to start a new paper, complex analysis. And in this video lecture, we shall study about the complex number system. Complex numbers. This is an introduction. Friends, complex numbers will study their evolution. While studying evolution of number systems in real analysis, we have studied that the history of natural numbers is as old as human civilization itself. Natural numbers were learned as men started counting their cattle, sheep and goats, etc. That's why natural number is also known as counting number. And how they are depicted, friends? They are depicted as n is equal to 1, 2, 3 and so on. The set of integers I or Z was evolved to incorporate the arithmetic operation of subtraction. Z is, we know friends, -2, -1, 0, 1, 2 and so on. But we also know the system of whole numbers, and this was evolved with the advent of the concept of 0, and when this was added to the counting numbers or natural number system, this became the whole number system. And this 0, 1, 2, 3, when 0 union of natural numbers become the whole number system. And when the negative numbers, negative integers along with 0 and positive integers, they form the integers, which are denoted by the set Z, or also in some books it is denoted by I. And hence we have also studied that the rational number system evolved to incorporate with the arithmetic operation division. This was developed, the system of integers was developed to incorporate minus or subtraction, and the set of real numbers which is denoted by Q, where Q, every member, Q is the collection of all the x's, where x can be expressed as P by Q, where friends P and Q are integers and Q is not equal to 0, because 1 by 0 does not have any sense. Hence, these types of numbers, suppose 2 by 3, 4 by 5, we have already studied, are called the rational numbers, which is evolved to incorporate with the arithmetic operation of division. And the irrational numbers, friends, evolved from finding the hypotenuse of a bilateral triangle C of unit 1. If this is 1 and this is 1, this is the perpendicular and this is the base, this is the hypotenuse, then we know this will be equal to √2. We found the number √2 there. And finding the circumference and area of a circle, if this is a circle and if it is its radius, then the circumference is twice pi r and its area is pi r square. We come across with the number pi. And in development of the natural logarithm system, log e x, this is known as ln x, the natural logarithm. And here the base of the natural logarithm e, all these numbers √2, pi, e, we came across with the development of mathematics. These numbers cannot be expressed in the form of p by q. So these numbers and many other numbers, cube root of 7, fifth root of 11, and there are also many other numbers which cannot be expressed in the form of p by q or in the form of rational numbers, and these were called irrational numbers denoted by qc. And finally, friends, the set of real numbers which is denoted by R is the sum of the rational numbers and the irrational numbers. All these things we had studied in the evolution of the real number system. And the evolution did not ended with the real numbers, but it continued. The complex numbers were evolved with finding out the square root of negative numbers. The complex numbers evolved with finding square root of negative numbers. Root over -1 is called, friends, iota and is denoted by I. And what is a complex number? Every number of the form a plus bi, where a and b are real numbers and I is the iota is equal to root over -1 is called a complex number. Any number which can be expressed in the form of a plus bi, where a, b are real numbers and iota is root over -1 is a complex numbers. For example, 2 plus 3i, -2 plus 5i, -3 plus -7i, -11 plus 5i. All these are examples of complex number. Thank you, friends, for watching this video.